Hi, so I'm going to be going over weekly review question 6. So the question for this week is a design experiment to test if P53 levels are going to, or P53 is going to increase transcription in UV treated cells. So first, what we're going to do to experiments we could do to test this is transfection, qPCR, and a Western blot. So for transfection, we're going to remove the RNA. So the sRNA is going to be released in transfection, and it's basically a natural way of exocytosis. For qPCR and Western blot, so qPCR is going to measure how much RNA we have, and then the Western blot is going to measure the protein levels in this experiment. Let me just grab my eraser here. And it's also going to identify the proteins. So now for the steps to do this. So the first step is you're going to buy the GAD45 sRNA plus the control from a company that sells it. Next, you are going to set up different plates of cells. So we're going to have 6 plates. This is going to be plus UV. This is going to be minus UV. So we're going to have our SI GAD45 that we bought. Then we're going to have our control, and then we're going to have just cells. So this is our cells with us, GAD45, cells with our control that we bought, and just cells. And it's going to be the same thing for these, but these are going to be treated with UV. And then this third step is we're going to transfect. So we're going to have we're going to transfect those cells. So then we'll have the same 6 plates going into step 4. So now for step 4, we're going to treat with UV. This is usually around 40-ish seconds, and we're gonna wait 24 to 48 hours to let the UV really hit it. So then we're gonna damage the DNA using the UV, and then for step 5, we are going to collect the RNA and the proteins from each of the 6 plates, and do a qPCR test and a Western blot. Then for step 6, so after we've done the Western blot and the qPCR, we're going to wash each of the 6 plates with PBS. And then we're going to permeate or poke holes in the membrane of our cells. We're going to inject with iodine. So our section that we want to see if it's transcribed more is going to glow. And then we're going to degrade our RNA or RNase A. So that's step 6. So the outcome, so we're going to see how the cell cycle is affected. So we're going to have 6 data graphs that we're going to get from this. And so this is no UV and this is UV. For these 3, no UV. And so we would expect the normal for all of these. So the normal, nothing is going to change, we expect with the UV. So we expected the normal process of the cell cycle to occur. Now, this is going to be our siRNA GAD45. It's going to be our control, and this is going to be our normal cells. So these are going to be a little bit different. So our cells alone and our control, we're going to expect to stop in G1 and not be able to go to S phase. We're going to expect our normal, or our siRNA with GAD5 to be normal, because this would indicate that the P53 transcribed the GAD45 correctly. And then we could measure through the Western blot and the qPCR to see how much protein and how much RNA was transcribed to see if P53 is going to increase in the cell, that in the GAD45. And you could set up an experiment with cells that have P53 and cells that don't have P53 to relate these values to see if the P53 or the transcription, the protein levels and the RNA levels are more in the cells with P53 or in the cells without P53 to see if P53 increases transcription in GAD45. So you would follow the same thing just with cells that don't have P53, and these ones would have P53. So that is it.